Okay, so hopefully sound levels come out okay on everything. So thanks for having me here today. What I'm going to talk about is bridging the divide between industry and academia and XR, and to be fair, I'm also going to kind of mix in a lot of digital twins into the discussion because that's sort of my thing is digital twins. But I'm going to weave together XR and digital twins in a way that I hope is useful for everybody and kind of has an overall effective framework. So I'm going to cover three things. The first of all is just kind of adapting to industry. And I'm going to talk a little bit about my own experience. I'm going to talk about how industrial customers think, a little bit about how the industry is organized. Then I'm going to transition into XR and digital twin adoption. Why do customers make the decision to use these tools? What gets in the way of adoption? What are the opportunities? What are the downsides? And then I'm going to talk about trends. And kind of like the dude said, or to paraphrase, it's just my opinion, man. So don't take it to heart, but hopefully some of the trends that I cover are useful. So how'd I get here? Grew up in Kentucky, poor, and really didn't have money to go to school. Ended up going to a school called Kettering University in Flint. It was called General Motors Institute at the time that I went there, because it was still owned by GM. And I worked for GM as a co-op at the time. And that's what brought me to Michigan. I had just turned 17 and was like wide-eyed, got up here. And it was great. I got a bachelor's in mechanical engineering with a minor in electrical engineering, focus on digital control systems. That ended up, before too long, getting me on an expat assignment in Europe. So I lived in Luxembourg, and what I'm showing there, this is a wildly inaccurate scale because the entire country of Luxembourg is about as big as Washtenaw County. So yeah, it was a really small place, but I got to travel all over, do all kinds of interesting things, kind of expanded my view of the world. Most interesting story from that time was discovering a KGB agent conducting industrial espionage during a trip to the Soviet Union in 1990. And he didn't see me observe him, and him and a few other people. So I feel like that was my probably one and only experience as an international spy. GM spun off Delphi in 1999. I was part of that spinoff. Kind of during that same time, actually, I started Michigan a little before that, went and got my evening MBA. So that took 5 years and pretty much finished that up right around when the spinoff happened. That was fine for a while, got lots of good experience. By the way, I moved back to Michigan after Luxembourg. After a while, I was just like, you know what, this is nuts. So I quit. Went to work for Autodesk, and just kind of a crazy connection landed me there. I was at Autodesk for about 9 years, and that was a great experience. And really, that was my first time working in any kind of a tech field, and did a year working for a small consulting firm, actually based here in Ann Arbor, and then went to Unity in 2017, up until just over a year ago when I quit Unity and started my own business, which is Twinsight Consulting, and focused on digital twins and everything related to digital twins. But obviously, I've got a lot of perspective from my time working in the manufacturing industry, working globally, and working in the tech field. So, this is my perspective on those things. So a few things I would suggest as takeaways from my experience. The first is embrace change. You don't know how things are going to unfold. No matter how good you are at predicting things, life is going to throw curveballs at you. Some of those curveballs are challenges. Some of those curveballs are opportunities. It's really helpful to learn to tell the difference between those two. But things are going to change, and just embrace that change and go with it. And also ultimately learn to drive the change in ways that are beneficial to the world and beneficial to you. Second thing is make your own luck. Some of the best things that have happened to me have happened simply because I did something one time and somebody noticed, and like 5 years later, that resulted in an opportunity coming up. And you just never know where something that you do in the past is going to come back and present an opportunity in the future. The more you put yourself out there, the more opportunities you create for luck to happen. It's a numbers game. The more likely it is that, that you're going to have good luck. Just do it in a positive way is my only advice. Third thing is lean into your strengths. Everybody's got their strengths, and especially when you're earlier in your career, lean into those. Use them effectively. Don't use them exclusively, and I'm going to talk about that in a bit, but make use of them. And that's your stock in trade, and you can kind of build out from there. But also recognize your weaknesses, because everybody also has their weaknesses, or maybe a better way of putting that is undeveloped parts of their personality or their business experience or their technical experience or something else. Know what those are and adapt to them. You can learn to overcome them, but you can't overcome everything. And the real key is that you want to surround yourself with people who complement you and learn to trust and respect their point of view. And if, there are things I know I'm not good at still, and if there's somebody who I know and trust, who I know is good at that, I can ask them, and that's and especially when you're building a team, and especially when you get into a leadership position, it's critically important to do that. So the most effective leaders are those who know what their strengths are, know what their weaknesses are, and they surround themselves with people who compensate for the weaknesses, and they give those people the authority and autonomy to kind of help balance the team. I also want to talk a little bit about the value of skills over time. So, I've put these in 3 categories: technical skills, interpersonal skills, and organizational skills. I'll talk about political skills, which isn't on the slide, and there's a special kind of wrinkle on political skills. So technical skills, obviously you guys are technical. So, if you weren't technical, if you didn't have technical skills, you wouldn't be here. But technical skills are, they can be ephemeral. So, the language that's hot today is going to be obsolete in 20 years, most likely. In some ways, even the idea of how we code today with new tools, generative AI tools and tools like Cursors, a new IDE that's out there, are starting to kind of like simplify the process of coding to the point where it's become more about deciding what you want to do as opposed to all of the intermediate details of how to do it. Now, I will contradict myself here a bit. It's still important to understand how the technology works. It's just that the day-to-day way in which you use the technology, effectively and productively may not be the same as it is today. But ultimately, even you can't just take a piece of code that Gen AI spits out and say, okay, I'm done, it's good. But you need to learn how to use tools like Gen AI to generate your code in a way, and then know what to look for when you go in and open it up and look at it. So it's more the way you use technology is going to change over time and evolve, and new technologies are going to emerge. Last couple of years have been a great example of that. So the technical skills continue to be important. Stay invested in technology, but don't make technology the only thing that you rely on. So interpersonal skills, everything that you need to get done in the world, period. I don't care, you could be in a research team, you could be at a Fortune 500 company. A lot of it is about how to understand what motivates people, what people are afraid of, all those kinds of things, and learn to influence people in a positive way and learn to be influenced by other people in a positive way to be effective. Because especially as you move into increasing areas of responsibility, if you become a manager, your success as a manager is no longer about what you can do, it's about what you can enable other people to do. And it's a big mindset change, and it requires good interpersonal skills. And that also translates into organizational skills, which are related, but more in how do different parts of a business or organization function, and you need to learn how those puzzle pieces fit together in a way to leverage the organization to achieve things you want to achieve. And I mentioned I would talk about political skills too, and I promise I'm not going to spend too much time on the generalities, but it's good to set a foundation on the generalities. There's good politics and there's bad politics. When people are doing things, it's for a reason. Good politics is influencing them to do something that's good for them, that's good for the company, that's good for customers. There's a benefit that comes out of it. Bad politics, we all know what it is. It's backstabbing, undermining people and such, and that's toxic, and you don't want to go that direction. But I will also say there will always be people who practice toxic politics, so be savvy to recognize it and understand it and be able to work around it when you see it happening. It's inevitable. Industry landscape. So there are two things I left off this chart. I left off academia and I left off government because I really don't know anything about either one. I've never worked in either one, so I would be totally the wrong person to provide advice to you. I have worked at a services provider. I've never worked at an infrastructure provider, like AWS or somebody, but I've worked with enough of them to understand. But the two that I'm going to end up spending most of the time on in this presentation are the end user customer and the solution provider. And I'll describe what I mean by all four of these real quickly. The end user is just, could be Ford. It could be Baxter Healthcare or Pfizer or, just about any kind of company that's doing something. It's not a tech company, but they're using technology in a way that benefits either their revenue, their technical innovation edge. They can use it for cost savings. It could be any of a number of reasons why they're using technology, but they're using technology that's coming from solution providers, often together with services providers, because end users commonly don't have big internal technical staffs, so they need to bring people in who've got that expertise, and they're using solutions from the solution provider. What is a solution provider? Unity's a solution provider. Meta's a solution provider. Any company that's providing hardware, software, technology is a solution provider. And then the infrastructure providers are just, AWS, Google, Microsoft with Azure, things like that, and Oracle and others. Another thing is kind of something to look for, and I meant to say at the beginning of this presentation, but failed to do so, that I'm putting this presentation together in a way that I want to make it something that I would have appreciated getting 40 some years ago when I was in your shoes. And so some of this is also tailored toward when you're going out in the job market, what to look for as well. So one of the things is, what's your happy place? I've kind of got this spectrum here of security and stability on the one side, innovation and change on the other side. You go further on these extremes and you're going to get complete calcification and lack of progress on the one end and complete chaos on the other end, and I would recommend staying away from those extremes. But within this area, there's no one right answer. If you're in tech, you're generally going to be oriented more toward the innovation and change side, but you need to know there is a difference between change and chaos, and you need to find what's right for you. Big companies tend to be a little slower moving. Small companies tend to be a little bit more nimble. The best option is a big company that has managed to stay innovative. Oftentimes you'll find more maybe mid-sized companies are where the real innovation happens. A small company that's static and secure, thinks it's secure and stable but isn't changing, is not the place to be. So what does it take to succeed in an end user company? First thing you need to do, look for meaningful problems. Don't put the tech first, put the problem first. You need to think about what's important to the business, and that's going to be different for every customer. And it's not necessarily a business, it could be a different kind of organization. But you really need to look at what are these meaningful problems that if we solve this problem, it'll make a real impact. And then you need to drive change with the right tech fit. And I'm talking about from within an end user company at this point. And you need to try to find the match between here's the problem, here's the technology, how do I find something so that I can make this go together in a way that solves the problem? There's real magic that happens when you do that. Third thing, you need to build your network. Especially in an end user company, the real opportunities come from cross-pollination across companies, both technology companies, end user companies, coalitions across end user companies. You have to be careful about non-competitive issues there, but you want to build your network and you want to have connections to other areas because otherwise you'll have blind spots. You don't want blind spots. And then finally, I would say develop mentor relationships. It's super important. Mentor doesn't need to be within your own company. It can be outside of your company, but it should be somebody who has experience in the kind of things that you've done, but has a different perspective on it and can kind of look at things with a, with a little bit of a detached view and give you some advice on that front. And somebody you can just, who'll listen to you. If you're at a solution provider, my recommendation is all the exact same stuff that you did at that you need to do in an end user company, but you've got the additional challenge of delivering solutions for those end user companies. So you need to know what problems do end user customers have. Try to find the right tech fit. But now instead of working within a company trying to just do this on a smaller scale, you're now trying to do this on a bigger scale, and you've got to make sure that not only does one company have this problem, but there are hundreds of companies out there who all have the same problem, and hey, we can solve that problem. So all the end user stuff. Plus, you need to think about a technology-focused career versus a customer-facing career. So especially a large tech company, especially if you're in more of a research role, you can get into a role where you don't talk to customers very often and you're very technical focused. You're deep into things. Or you can have more of a customer-facing career where you're at the interface between, and you're naturally in a sales-adjacent role there, where you're more of an interface between the solution provider and the customer. The benefit to that is you get to see all the problems that the customer is having. My advice would be, even if you go into purely a tech role, find some way to spend time with customers, because it's just eye-opening. Even if you're working in a research lab, if you have a chance to meet some customers and understand their problems, it can be really eye-opening to say, oh, because there's things you wouldn't have known otherwise. And then finally, anticipate where change is going to happen. That's hard to do, but it's essential, because you need to always be thinking ahead, what's going to happen next, and you're going to have to start, the company's going to have to start working on innovations to address those upcoming changes. I mentioned the word cross-pollination before. It's really important that you don't get buried down too deep in one area without a lot of connectivity to other areas. So, you can be a mile wide and an inch deep. That's probably a little extreme, because then you don't have anything special in any given areas. You're just a complete generalist. Or you can be an extreme verticalist, and that's probably not great either. You want to find some happy medium with a T, where you have enough experience where you can reach across different fields, but you also have some areas where you bring your strengths to the table and you've got something to contribute. So that kind of T model is perfect. All right, I'm going to talk about how industry makes decisions. We would like to think that industrial customers are like Mr. Spock, emotionless, perfectly logical, just make the decisions based on the facts, and nothing could be further from the truth. So it is true that just about every business decision involves some metrics. Oftentimes, those are things like the impact on revenue, cost savings, the required investment. You get net present value metrics and all the kinds of stuff that you learn in an MBA program. But oftentimes, there are other initiatives. It could be a safety initiative. I distinctly remember a meeting with one customer where they were implementing a new XR training process, and the reason they did that was within the previous 6 months, 3 people had been either seriously injured or killed by industrial accidents in these facilities that they had. And I'm like, well, that's a pretty good reason to do something. So sometimes there are things that are not purely monetary. It could be something about, proposal to enter a new market. There are lots of reasons customers do that, but there are all kinds of metrics around it. But metrics aren't everything. At the end of the day, metrics end up being numbers in a spreadsheet. Numbers in a spreadsheet are pretty static and don't actually mean anything. So there's the vendor and the product. What's the vendor's reputation? What's their support like? Have they had security breaches? All of these kinds of things. And it always boils down to, can we trust the vendor? Can we trust the product? And that becomes a really big factor. I know of customers, I've been told by customers that they would not work with a company because 15 years earlier, the vendor had done something really bad. The people who were responsible for that decision weren't there anymore. They didn't care. As far as they were concerned, that vendor was on their list and was going to stay on their list until they weren't around anymore. Internal factors. So internal factors are things like, can we actually absorb this? You know, you could have something that's a perfect solution for a customer, or a perfect solution in general, but for a given customer, they're not ready to take that on. They don't have the internal organizational capability. They don't have the robust digital infrastructure or the clean data or whatever it is that's needed to actually succeed. There can be political factors at work that get in the way of things. So there are all kinds of internal factors that can be reasons why a company does or doesn't do something. And finally, there's emotion. The person making decisions is going to be driven by things like career aspirations or fear of negative career implications or resentment against the person who's suggesting this or rivalries and such. And we'd all like to think those things don't happen. They happen. So all of these are things that you kind of have to watch out for. And while the metrics and the vendor and product and the internal factors are the most critical things, don't underweight the value of emotion. Another thing that I'd say is look for constraints. In almost any kind of an organization, you're going to have problems that are bigger than others. So think of it like a Pareto model, where you've got this thing is really important, something else next. If you're not working on one of the top 5 things or something, then you're not solving the biggest problems. And oftentimes what you find is if you break that constraint, it improves things. Maybe products get down the line a little bit faster, or maybe the yield of a product is improved, or maybe customer satisfaction goes up by 2% or something like that. But it's a real change. And then what you find is there's another constraint. And so a useful way of looking at this is, what are the series of constraints that you can break to get to some objective? And that's where you ought to be focusing your energies. If we look at the adoption of digital twins and XR, I kind of adapted this from the famous Gartner hype cycle. I have my opinions about Gartner. They're not entirely positive, but I won't say any more on that. But their hype cycle is kind of a useful model. And if you look at things, there are tools like use of XR for design review. It's common. It's there. It's productive. Companies have been using it for years. Training is right up there too. Training is, I would say, at this point, probably the single most important use of XR in industry, bar none, because it just works so well. You get Gen AI really becoming super valuable, super important. Most things, smart manufacturing, smart other things are working, starting to get there. HMI is starting to get there. Then there are things where, like smart city, it's kind of a buzzword, but no proof has been there. And then I would go all the way to the left, predictive AI. It's got a lot of problems. So today, as it stands, it's a lot of companies are selling hope on predictive AI, but I think the reality doesn't live up to it. And I'll talk about that a bit later. Yes?
Wait, what exactly is HMI?
I'm sorry. HMI, human-machine interface. One thing that I worked on was using Unity. I pushed an initiative to use Unity for HMI. And now Mercedes has a new line of vehicles coming out next year where the entire dashboard is going to have Unity running in it. And a lot of the 3D elements in the vehicle are Unity. Not the entire operating system of the dashboard, but quite a bit of it. And I think there are currently something like 60 different electric vehicle models on the road in China today using Unity in the dashboard. So, essentially 3D-based human-machine interface systems. Common barriers to adoption. First one, unclear direction. Like the saying goes, if you don't know where you're going, any road will get you there. Anybody who saw the presentation in Detroit will recognize this slide. But effectively, you need to have some idea what the objectives are for anything that you're doing. Otherwise, things just have a tendency to spiral in all kinds of different directions, and you're not going to end up anywhere close to what you want. Second issue is compatibility challenges. And the earlier speaker was talking a little bit about, well, this toolkit and that toolkit, and it's getting better, but you'll find that it's one thing to solve the technology compatibility challenges, but then when you get inside a company, oftentimes they've got a lot of legacy systems, and you might have some 20-year-old piece of technology that you need to integrate with. This is especially true when you start getting into digital twins, and you just have to watch out for it. And that can just slow down or even stop the adoption of new technology initiatives. Complexity is another one. I debated using this because this is a cockpit of an Airbus A350, which is a phenomenal aircraft. And if you're an A350 pilot, I'm sure you can step into this and I feel right at home. For me, if I stepped into this, I'd break out into a cold sweat. And the key is, what's the level of complexity that the customer can adopt? And who's going to be using these tools? What are their skill sets? And if you haven't matched the complexity of whatever it is that you're developing to the people who are using it, you're going to have a problem. So you don't want to stick me in that cockpit, in other words. Another factor is maintainability. Doesn't apply to prototypes, doesn't apply to quick one-offs and so forth. That's fine. But if you're ever developing something for an enterprise or business use case or anything that's going to be used for any length of time, you need to think about, how am I going to be able to maintain this over time? And it's everything from making sure the code's commented correctly to making sure that you're using standards in a way that you can easily swap out one piece of the solution when it becomes obsolete and replace it with something else. Another thing is weak foundations. I kind of alluded to this earlier. Some companies just are a little bit shambolic internally, and it's surprising sometimes how shambolic they can be. And if the data's a mess, if it's not properly organized or attributed or anything else, or if the organizational structures within the company just can't keep things alive, you've got to be careful about it. You can't build a 100-ton building on top of a foundation that can only take 3 tons or something like that. So you need to think about the foundations you're building on. Skill gaps. This is a big one. So skill gaps, effectively, if you're missing, you need to think about what skills are needed to implement something. And this becomes a bigger and bigger problem the larger the team that you're dealing with. So if you've got a small team and you can learn a few things and hack things together, kind of like here at the Hackathon, that's great. No problems at all. But if you're in a larger organization and you don't really have somebody who's an AI expert on the team, and AI is something that is eventually going to be a critical component of the system you're developing, you'd better look at bolstering those skill gaps before proceeding much further. And they can get in the way. Inadequate user involvement or training is a real problem. You can have the best mousetrap in the world, but if nobody knows how to use it effectively, and if everybody who needs to use it doesn't know how to use it, you've got a problem. And the last thing I would say is, think of tech as a spice, not the meal. I really wanted to get a picture of from Dune with this, but I couldn't find any copyright-free images, so you can imagine the blue eyes instead of this. But effectively, just like when you're cooking something, if all you did was make a meal out of the spices, not the meal itself, it would be gut-wrenching. But companies are trying to achieve something, and much of their business already are a lot of the raw ingredients, the meat and the vegetables or whatever that go into the meal. But what tech does is it makes it delicious. You're able to kind of mix the technology in with the core elements to make something that is truly delicious. All right, I'm going to talk about digital twin building blocks, and I promise XR is one of these. This comes from a presentation I did earlier this year at a conference down in Houston. But I think it's useful to think about what's the real core of the systems that we're building on, and kind of what are the optional components of those systems. And I'm hoping by the end of this, it kind of shows a picture of how things tie together. This is really oriented towards digital twins, but you can think XR, hear XR when I say some of these things. First is the core of every system is the data. So you've got the live or historical data and metadata and historical data. You've got data management, because any kind of system, unless it's a one-off, that data is going to change over time. It'll become a complete mess if you don't manage it. And oftentimes you're talking about federating data, because often what you're dealing with is not data from one system, but data from this system, and this system, and this system, and this system. I'm involved in responding to a lot of requests for proposals from customers, and they are all like, I want this thing to work with that thing, and they don't know how to make the things work together. So there's a lot of federation of data that goes on. Then surrounding that, you've got things like, well, you've got to have generally speaking, a lot of times you'll have spatial data. So spatial data, 3D data, reality capture, could be GIS data, geographical information systems. There's all kinds of 3D data that you can pull in. You've got time and sequence analysis, because sometimes the importance of something doesn't come from just a static view of what it is, but how it changes over time. You've got visualization engines. So this could be anything from a simple 2D animation on phone to a full-blown immersive XR experience. And really the important thing is thinking about what is the minimum experience needed to provide something really useful for the user. And sometimes XR is exactly what you need, and sometimes it's overkill, and you just need to know where the difference is. You need to incorporate oftentimes behavioral models that can come from simulations. How does this machine work? How do these people behave? Those can, especially when you're getting into more complex digital twins, those can become elements of it. Simulation is important. And by simulation, I mean kind of traditional simulation, finite element analysis, computational fluid dynamics, all that kind of stuff. And finally, AI and ML. I think it's going to become increasingly, don't know if the word I'm looking for is difficult or wrong, but one of those somewhere in that vicinity, to create new systems without incorporating some element of AI and ML, just because the tools are simply so powerful and so productive that used properly, they can provide tremendous benefit. I'm just going to really quickly fly through this, because otherwise that would dig into too much. But what kind of data do you integrate here? You've got model data, CAD data, computer-aided design data, building information modeling, just raw polygonal data. You've got data from reality capture. You've got synthetic data. I gave a presentation on that in Detroit about a month ago. So much work that's going on in synthetic data right now. You've got your live and historical data that could come, say, for example, from machines on the production floor, where you've got some Modbus link and you're collecting all the historical data from sensors out on the plant floor in a manufacturing system. You've got IT systems like enterprise resource planning or maintenance systems and such. Oftentimes, those are valuable sources of data. What the right data to use is obviously depends on the application, but there are lots of places the data could come from. And then finally, most important, human knowledge. Frontline workers, technicians, engineers, managers, consultants all often have a perspective on things that if you don't understand it, you're going to miss a trick on a system. And then I've got governance framework. This is a little bit more enterprise focused, so I'll go over this quickly. System architecture and standards. Security, I will say, I don't care how big or small a system is that you're designing in today's world, if you're not thinking about security, you've got a problem. I'm working on a project with a food and beverage customer right now, and it's like, the security has to be ironclad, because if you haven't addressed security, somebody's going to come in and mess around with your system. I'll kind of glide over the rest of these because they're not as appropriate for this group. All right, and here's trends. Like I said before, these are just my opinions, man, but I think there's something here. First trend, generative and agentic AI. I don't have to say much about generative AI. We've all played around with ChatGPT or Claude or whatever. Everybody likes to laugh at the limitations of the systems, and yes, they have their limitations still, but they're also incredibly valuable. I will also say that I've seen some stuff that people are developing right now, and I really think that within the next year or two, we're going to see an even bigger level of evolution of what some of these tools can do. It's just mind-blowing, absolutely mind-blowing, some of the capabilities. Also, there's a big trend toward agentic AI, which is instead of just responding to a prompt, where the AI has agency, where it can do certain things on its own. And that is going to unlock, I would say, both a lot of power and a lot of risk that needs to be managed properly. Predictive AI. This is a mixed bag. So, you could say, for example, I'm going to build an AI system that is going to predict the daily closing price of the NASDAQ every day for the next year. Now, if you could do that, you would end up being a very, very wealthy person. But the fact of the matter is, the inherent system that you're trying to predict is chaotic. And there are just it's all just one big bag of probabilities, and you simply cannot know all of the things that are going to go into that prediction. And even if you did, it's still chaotic. So I would say with predictive AI, take it with an entire shaker of salt. There are things that can be predicted if problems are well characterized and relatively stable and you can identify the inputs and such. Fine. That's a good application for predictive AI. If it involves elements of chaos and uncertainty and the classic butterfly flaps its wings in Brazil and you get a thunderstorm in Louisiana kind of thing, then yeah, think twice. There have been so many things that have, I would say, evil might be too strong of a word, but the use of some of these technologies in like social programs, like predicting the chances that criminal offenders are going to reoffend and then treating them differently based on predictions. This has actually been done in a particular state. That kind of stuff's pretty bad. So I would say be very careful. Something that I am enthusiastic about is, I don't know if this is the right term to use or not, multimodal and multi-model integration. I think one of the next great leaps that's going to come is being able to integrate in different types of systems and even integrating, I'm talking AI here, integrating AI systems with non-AI systems. So say, for example, if you've got a system that is able to provide simulations of a particular system, combining that with the power of a Gen AI system, you can get some really interesting outcomes from it. And some of the work that's being done there is showing some really incredible promise. It's effectively giving superpowers to AI. Much like we use, I don't know, a calculator on a smartphone or something like that to kind of augment our brains, Gen AI is going to be able to be augmented as well in that way. A related, I would say, maybe I could have even put this on the same slide, thing is reduced order simulation. So I don't know, I suspect you're all computer science majors or something close to that. When it comes to a lot of engineering fields, you can have these incredibly detailed simulations. You've got like the entire structure of an aircraft or something, and you can do finite element analysis under various conditions and even mixed analysis where you have simulate the fluid flow over a wing and the resulting structural impact, and these are really complicated calculations. They also take a huge amount of computing power, and they don't want anything close to real time. But there's some really interesting work being done to basically conduct a bunch of simulations, learn the results of those simulations with machine learning, and effectively create a neural network that is a reduced order model of the simulation so that you can throw new data at that neural network and get practically real-time output that is accurate, as long as you're within the bounds of what the original simulation covered. You can't extrapolate. And that has some surprisingly powerful uses, even in something like training, where you've got something where you have an object that you want to respond realistically. I've seen this used for like port worker training, where you're running a crane and you've got something on the end of a cable and it swings when you move it and that kind of stuff. Being able to accurately represent that in a XR training experience is really important. But you can't run all of those calculations in real time, but using a reduced order model, you can. So there are some really interesting ways you can tie these things together. Reality capture, photogrammetry is not new, LiDAR is not new. Oh, by the way, on the previous slide, there's a company in Sweden called Algorix that is doing some really interesting work in that area. So anyway, back to reality capture. Photogrammetry, LiDAR are not new. Although they're getting better and more accessible, and it's amazing what you can do with your iPhone with Polycam nowadays. But also now what's being done with NERF, neural radiance fields, and reconstructing objects from neural radiance fields, taking neural radiance field data, converting it into polygons, automatically detecting objects and segmenting those within a scene. There's incredibly powerful work that's going on there. I wouldn't be surprised within 5 years or so, you'd be able to walk around with your phone, scan everything in this room, and the chair would be the chair, the handrail would be a handrail, that kind of stuff. Synthetic data, I kind of alluded to that earlier. Synthetic data is going to become essential to the training of future AI systems. It's a little bit funky that you're generating data, sometimes with AI, not always, and they're using it to train AI, and as you can imagine, there's a lot of risk in there that, you get garbage in, garbage out, and in fact, what you get is garbage in, and then you get a garbage multiplier. So you have to be careful that synthetic data is robust and accurate, but it's also something that's essential to future progress. We were chatting about this a little bit earlier, form factors. So this is the Meta Orion. Form factors are just going to get more and more convenient and easier to use. And if you come back to this event in 10 years, the hardware that people are going to be using probably blow all of our minds. So, and that is just, there's going to be progress there. Particularly with the continued miniaturization of electronics, the continued innovation of optoelectronics, the continued improvement in batteries. The direction's clear on this. And the final thing I'm going to talk about is democratization. This is just more of a general trend that, unpredictable things happen when technology spread out throughout society. And those can be good and those can be bad, as we've seen with social media. But the use of this technology, not necessarily the creation of this technology, but the application and the use of this technology is going to impact more and more people in ways that most people don't understand yet. And you guys kind of understand this because you're in the middle of it. But it's going to have a lot of impact on society. And I will also say the other thing of democratization is it will open up the ability to create experiences to more and more people. I wouldn't be surprised that in a few years you could have somebody who's in high school doing some of the things that we're doing today, just because the tools have become so convenient and so easy to use. So that is everything. I'll take questions if there are any. So thank you. Yes. Yes.
What stage did that happen?
So I got this. There's a great book, and I'm trying to remember. It's Arvind and Sayash are their first names. It's a professor and a grad student at Princeton who wrote this book called AI Snake Oil. Despite the name, they also, by the way, have a Substack that is great. And the name of the book sounds a little provocative. It's not a negative book on AI. What it does is it calls out what are the capabilities and what are the limitations. So I got the example out of that book. I want to say it was a southern state, which, yeah, kind of checks out. I want to say it was Louisiana, but I'm not sure. I can't remember. But it was something, essentially they're predicting, using various factors to predict the likelihood of reoccurrence, and the end result was that the system had been trained on data on which people were more likely to be rearrested. Well, there were bias factors involved in who was more likely to be rearrested, and people were being essentially penalized because of the race. And it's pretty bad. It's awful.
It's interesting because, it makes you think about what other things that they could use, predictive models for. What if they replace juries with AI at some point?
Yes, exactly. I'm going to repeat that because the microphone won't pick up your question. The question was, well, what if these types of models were used for other things? Like, what if a jury, AI was used as an AI jury to judge whether somebody is guilty or innocent? So again, just repeating your question, I agree completely. And I think the problem is that oftentimes when new technology appears on the scene, people react to it as if, oh, wow, this is amazing, and we'll just do all these things with it, and driven by a profit motive, some people will promise things that the technology can't do, use it in ways in which it isn't appropriate, and then it causes a bunch of problems, and then eventually it gets regulated. But, let's face it, are any politicians really capable of understanding the impact of this today when the technology is still at a pretty nascent state? Not many. So, yeah, I worry about that, and it's something that, as a society, we have to keep an eye on. Andy, you had a question.
Yeah. So you talking about democratization. I was wondering if you meant more from an accessibility standpoint, a source standpoint, combination.
Democratization, you said? Yeah. Okay, so the question was what I meant about democratization. It's kind of a vague term, to be honest, and I would say in general, if you look at the barriers to anybody using this technology today, you guys are more aware of those barriers than just about anybody because you're fighting with them every day. And it's like, oh, I just want it to do this and I can't get it to do that. And then you fall down a rabbit hole in, SourceForge or something, where you're looking for some answer, and 8 hours later, after beating your head against the wall, you finally come up with the answer of how to do that. Well, that's going to dissuade a lot of people from adopting technology. So the easier it can be made for people to use the technology, and I think Gen AI is going to play a big role in this, the more people are going to adopt it. So it's really that simple. How do you break down the barriers to adoption?
Okay. So more from just user availability.
More from a user availability and fitting with the user's capabilities and understanding and skills. Yeah. Any other questions? All right. Well, thank you very much. I really appreciate it.
Thank you.
Bye.